Okay, everybody, this is a snapshot on truth tables. You should be familiar with the following concepts. That is, again, you should have looked over lecture notes, watched lecture, read the book. Key concepts: the four connectives, when they are true and false, the dominance of the connectives. Recall the truth values of the connectives, or, once again, you should be stopping the video and answering these questions, then watching the video. Or is true when at least one is true. All right? You need at least one of these to be true. And is true when both are true. The if and only if is true when both of these have the same truth value. Both have same truth value. So that's when this one's true. And then the troublemaker, of course, right? The if-then. The if-then is a conditional. Under the condition P is true, Q needs to be true. So that simply tells us the only time we have a contradiction is when P is true and Q is false. So this one's false only when you have a T gives an F. You need to have these memorized. Now, the negation of true is false. The negation of false is true. Now, this particular snapshot is about truth tables. Well, if you have a statement, for example, this statement here, often we'd like to know when this statement is true or false. That is, what is the truth value of this statement for all possible truth scenarios? What do we mean by truth scenarios? Well, since this has two parameters, P and Q, the following scenarios are possible. I'm going to make a little chart here. P could be true at the same time Q is. P could be true, but then Q might be false. P could be false, and Q could be true. P could be false, and Q could be false. That is, these are the four scenarios that are possible when working with two simple statements. These are all possible scenarios, right? There's nothing else that could happen because, again, P, Q are either true or false. Here are all the possible combinations. Look at the next example. Consider the statement given here. Once again, we'd like to know when that statement is true or false under all possible truth scenarios. Now here we're working with three parameters, so the following scenarios that are possible are given here. So we're working with P, Q, and OR. Well, there's a whole lot of them. All of them could be true. P and Q could be true. P could be true. Q could be false, and OR could be true. P could be true, Q false, OR false. P could be false, Q could be true, OR could be true. P could be false, Q could be true, and OR could be false. I'm running out of space here. But again, let's see, let's keep on going. P could be false, Q could be false, OR could be true, P could be false, Q could be false, and OR could be false. 1, 2, 3, 4, 5, 6, 7, 8. There were 8 possible scenarios here. Well, think about what we were doing with the snapshot on determining whether or not a statement was true under a particular scenario. All the various steps we went through. Well, we'd have to do that 8 times. Well, there's I guess a better way, let's say, and that's what we mean by a truth table, which we're going to get going on next. A convenient way of expressing the truth values associated with a statement for all possible scenarios is by way of a truth table. This is going to be explained in the following examples. We're going to construct truth tables associated with several different statements. Now, there's no one particular way of doing this. Typically, the suggestion is you work left to right, okay? Working in, keeping in mind, quote, the order of operations in a sense. You do parentheses first, that sort of thing. But again, you tend to work left to right, and you do something when you know you can work on it. You can't evaluate something necessarily until you know what you are evaluating, right? I'll explain that as we go along. But you tend to work left to right. Just keep in mind the order of dominance, parentheses, the usual typical stuff. So, looking at problem number 1, again, you should be stopping the video, giving this a try. You might do things a little bit different than me, but the last column we should all agree on. So, I'm going to look at this statement here, and I need to construct it. Well, if I work left to right, I have the negation of P here, right? So I need to know what the negation of P is. Well, when P is true, this is false. When P is true, this is false. When P is false, this is true. When P is false, this is true. Now I know when not P is true or false, right? I can't apply the if-then right now because I don't know what the right side is, right? Again, how can you evaluate an operator if you do not know what it is operating on, right? I do not know what P and Q is, so how can I work with the if-then statement at this point in time? But I can calculate P and Q. Why? Because I know what P and Q are under the 4 scenarios. And is true when they're both are true. They're both true. They're not both true. They're not both true. They're not both true, right? And it's true when they're both are true. This first scenario is the only time that's the case. Now that I have P, not P, and I also have P and Q, I am ready for the final column, which is the actual statement itself. Well, notice I am going to be working with not P, which is this column, along with P and Q, which is this column. They're being joined together by the if-then statement, right? So we have an if-then statement working between these 2 columns here. That is false only when a T gives an F, right? So I'm good with the first scenario. The second scenario. Third scenario, a T is given a false, so that is false. Fourth scenario, a T is given a false, so that's false. So now I know exactly when and under any circumstance when this is a true statement and when it's a false statement. So the first 2 scenarios end up leading to a true statement. The second 2 end up leading to a false statement. So now if I needed to, I could go back to the context of the problem. That is, find out exactly what P, Q were actually representing and evaluate it, right? So moving on to the next one. Once again, you should be working this out and then watching the video. I need to create a truth table for the following statement. Working left to right, I know I can evaluate P or Q. I have everything I need for it, right? Or it's true when at least one's true. One of them is, one of them is, one of them is. Nope. So that's the only time that one's false. I already have the Q column on the right-hand side. That's right here. And I have the P or Q. Now, the if and only if is commutative. So it really doesn't matter if this is on the left and that's on the right, or vice versa. If and only if is true when they both are true. The only one that's an issue is the if-then, because it does have a direction. So I am looking at this column. I am looking at this column. I'm comparing these two columns using an if and only if. They both have to have the same truth value. They have the same truth value. They don't. They have the same truth value. They don't. So here's the answer to the problem. This statement is true under the first scenario and the third scenario. It is false under the second and fourth. Okay, now we're getting a little bit more complex, right? But just keep in mind, you tend to work left to right, but again, parentheses may come into play here. The dominance might come into play here. Just try to work something out when you know you can work it out. All right, so if I look at 3, working left to right, I can't evaluate the if-then because I don't know what the right-hand side is. I can't evaluate the and because I don't know what the right-hand side is. So I need to go inside these parentheses. In order to evaluate the parentheses, I need to evaluate the negation of P, right? So the opposite of the P column, false, false, true, true. Now that I have that, and I have Q, I can evaluate the not P and Q, right? See how I'm reconstructing this? I'm working really left to right, but then inside out, right? I can't do something until I know what I'm operating on. That's the key point. Well, I am working with the third column and the second column, right? Not P and Q. That operator and is true when they both are true. They're not both true. They're not both true. This one's true, true, right? So both of them are true here, so it's true. They're not both true. So now I know when not P and Q is true, right? Well, now I can evaluate, use a different color, this right here, right? Because of the parentheses. So I'm going to be creating P and not P and Q, right? So I'm going to be working with the first column and the fourth column, right? This column and this column right here, correct? Well, that's an and operation, right? I'm working with and right here, right? So and is true when they both are true. So P, a true with a false is false. A true with a false is false. A false with a true is false. A false and a false is false. And is false. And is only true when both are true. We have no scenario where P is true at the same time, not P and Q is true. So there's our column there. Now we are ready to complete the entire statement. We are ready to complete Q implies P and not P and Q, right? So what columns are we working with? We are working with the second column and the fifth column. The operator we're working on is the if-then. When a T gives an F, it's false. An F gives a false, I'm okay. A T gives an F, it's false. A false gives a false, we're okay. So here's the answer. This is when our statement is either true or false. Okay? The one thing you have to be careful of is when you're working these things out, you tend to accidentally shift columns. So notice in the last one, I was working with the Q column, and I was working with this column here, right? So every now and then people tend to shift over. Just be careful. T gave an F, false. F gave an F, true. T gives an F, false. F gives an F, true. Number 4, again, stop the video, try the problem. Working left to right, I need the negation of Q, I need the negation of P. So the negation of Q false, true, false, true. The negation of P, false, false, true, true. All right. Now I'm ready for the OR. Not Q or not P. OR is true when at least one is. Nope. Yes, yes, and yes. I looked at these two columns, right? Because that's the two operands I was working on. The operator is the OR, right? So I'm looking for at least one T. Now looking at the problem, on the right hand side I can't do the negation because I need to know P and Q. P and Q, I'm working with the first two columns, right? I'm not working on a negation yet. This is not being applied yet. This is being applied to the entire statement P and Q, right? So and is true when they both are true. So both of them are true. No, no, and no. Now that I have P and Q, I'm gonna negate P and Q. Negating it, I'm negating this column here, right? The opposite true, false, true, true, true. So now we have the left-hand side, which is right here. We have the right-hand side, which is right here. So what I'm going to do is simply say, hey, here's where our final answer is going to be, right? That goes right there. Now, we are joining these together with the if and only if, right? And if and only if is true when they both are true. All right? Now, this is not the case. It is not the case. It is not the case. It is not the case. No matter what happens here, this statement right here is always a false statement. Whatever is going on here, whatever the context of this problem is, no matter what happens, this statement is always a contradiction. Notice they're all false. Anyway, let's move on. Once again, stop the video, work the problems. Looking at the problem, working left to right, I can calculate the negation of P. Remember that and is separating the left side from the right side, correct? So I'm negating P. If I negate P, we get false, false, true, true. On the right hand side, I need to calculate P or Q. At least one needs to be true. Now I'm going to negate it. You can stop the video, right? But you should be working the problems. I'm negating this column, right? Now I have the left side. I have the right side. So I'm now ready to complete the statement, right? I'm working with this column here, along with this column here. Then being joined with and is true when they both are true. So no, 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 and yes. This is the only place that these two are true at the same time. So that's the answer for number 5. Now let's work a little bit more complicated problem, because now we have 3 variables. We have 3 simple statements that this compound statement is made up of, right? But it doesn't change the way we do things. We just have more tedious work involved. We have 8 scenarios as opposed to simply 4 now. So looking at the statement, the first thing I'm going to do is construct not Q. So the opposite of the Q column, false, false, true, true, false, false, true, true. So I've done that. The next thing is not Q or, right? Well, I'm working with these two columns here, the OR column and the not Q column. It's an OR, so at least one needs to be true. I have at least one true. No. Yes. No. Yes. Yes. No. Yes. And yes. So I was working with this column and this column, right? Oh, just erased something. Let me put my not Q back in there. Okay, now I'll look on the right hand side. I need to calculate P or Q. I mean P or P, sorry. I need to calculate P and or, right? P and or. So I'm working with the first and the third column, right? It's an and, both need to be true. They are. Nope. They are. Nope. No, 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 no. So again, I'm looking at first and third column, looking for two T's because it's and, which is true only when they both are. They both are. No, yes, no, 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 no. Now that I have that, I'm ready to negate that column. The negation of P and or. So I'm negating this column. False, true, false, true, false. True, 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 true. And it doesn't hurt to repeat. I'm negating this one. False, true, false, true, 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 right? I have the left side, which is right here. I have the right side, which is right here. Those two are being joined with the if-then arrow, right? So I'm looking for a T gives an F because that is when it is false. A T gives an F, no good. F gives a T, I'm good. T gives an F, no. T gives a T, good. T gives a T, good. F gives a T, good. T gives a T, good. T gives a T, good. So here's the final answer. That is, the column associated with our statement is here. Hopefully everything's right. If you do happen to see a mistake or you disagree with something, please just let me know. Refer to the snapshot and the particular problem that you think I might have made an error. Again, this is unedited. When I catch a mistake, I fix it on the spot. But never know, all right? There's no guarantees here, all right? So it is the end. Good luck.